Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Dave Levine, who's a science and engineering manager at IDEX. Dave is a multi-year presenter at the Maine Science Festival and was a 5-Minute Genius speaker at this past year's festival event. There's no shortage of passion and inspiration from Dave when it comes to his work in process engineering, and I have a feeling you might be as excited about it as he is by the time you're done listening to our conversation. I hope you enjoy it. Dave, welcome to the Maine Science Podcast. It is a delight to have you. I've had the good fortune of knowing you for a fair number of years here because of your work being part of the Maine Science Festival. So I have a bit of an understanding of your background, but how did you get into engineering? And then we can dive into past work and current work.
Yeah, so my engineering background started, I was going to be a computer science major when I graduated high school. I thought that was the coolest thing in the world to do. I was good with computers. I liked programming and doing all that. I went to WPI in Worcester, Mass. As a computer science major. It was going to be awesome. And then I realized halfway through my freshman year that in order to be a computer science major, you had to kind of pass the classes. And I wasn't doing that for one of my classes. I just didn't understand it, didn't get it. So I failed the class. I found a new advisor, and they had just created this brand new program called manufacturing engineering. And basically what that is you take a little of this class, a little of that class, you get a kind of a broad knowledge. And really that kind of resonated with me. I wasn't that real expert in one area. I became knowledgeable in a lot of different things. And what that allowed me to do was take my knowledge and apply it to anything. My first job out of college, I worked for Lockheed Martin. They made communication satellites. So I have experience doing that, but it's very low volume. I moved from there to a company that was in the wire bonding industry, making semiconductors or making machines that made semiconductors. Medium volume type stuff. I moved into the automotive area where we were making steering and suspension components, high volume stuff. And now I work at IDEX making components for veterinary diagnostics, very, very high volume. So it doesn't matter the volume. I work in the process. I'm that jack of all trades, master of none type of guy. That's me.
So you said, you worked in the low volume, medium volume, high volume. Just so people understand, when you first get out of school and you go work for Lockheed Martin, you're not doing what you're doing now, which is more managing a team from conversations we've had. Correct. So when you first get out with a manufacturing systems engineering, which sounds to me very similar to an engineering degree that was at RPI, which is where I went to school, which is industrial engineering, where you learn pieces of everything.
Yep.
What's your job at Lockheed Martin?
So my first job at Lockheed Martin, I was in a training program. This was really something cool that WPI was able to do, was they put me on a 2-year rotation where I did 4 or 6-month rotations. My first job, I was in quality engineering, where they were making boards for the satellite. And I was ensuring that the manufacturing process had the right quality built into it. And then I did some other things. I was in environmental health and safety, so I got some exposure to that. I got some exposure to production planning. So I got a lot of different hands-on stuff. But once I started really getting into my career, I was that process engineer. Whatever they were building, I would look and try to make the process more efficient, more clean. You reduce the amount of scrap, those types of things. With process engineering, there's a 3-sided triangle. You have cost, you have speed, and you have quality. And usually you can get 2 out of those 3. So if it's going to be fast and it's going to be cheap, you're not going to have good quality. But if it's going to be fast and good quality, it's not going to be cheap. My goal is to make all 3 sides of that triangle work.
How often have you been able to do that?
It varies throughout my career. I've done things in one of my jobs where I was able to reduce the production of our instrument by over 100 person hours. So by reducing the time it takes to build, all those hours that go into it now gets cheaper. In my current job, we reduced the amount of desiccant we used in one of our devices. So the desiccant is just a drying agent. We used to use a 3-gram desiccant. We're now using 1 gram. So now we're not only saving on the cost of the desiccant, it's the cost of the material that the desiccant's in, and all the silica is no longer a waste. So that was a savings of almost $2 million a year for us.
Wow. And there's actually a big impact. Well, big is in relative terms, but that is more than just what you have all saved. It also reduces significant waste. I imagine if everybody was able to do that, the waste reduction would be pretty significant across the board.
Exactly. And that's why we use the lean mantra. And lean is based in the automotive industry. And it's basically looking at all the wastes that can be in a system and eliminating them as best you can. So, and waste doesn't necessarily have to be scrap and things that you throw away, but there's things like transportation that can moving parts from point A to point B. Excess inventory is a waste. So if you have too much stuff on your shelf that's not getting sold, that's a waste. Waiting time, overproduction, underproduction, those are types of waste that you have to look at, as well as scrap.
So this is really interesting because I don't think most people who think about engineering think about the process piece of it. I totally appreciate the jack of all trades, master of none part, but you really do need to know about a lot of different types of engineering from the perspective of how things fit together, how things are designed and made. But it seems to me you have to have a much higher overall view, like a 10,000 level view of what's happening so that you can see the whole process and how it fits together. It's almost like a jigsaw puzzle.
It's exactly like a jigsaw puzzle. And there's electrical components, mechanical components, computer programming components that all go together. And if there's a problem with something, I'll look at the whole system, figure out where the problem is, and then go get my subject matter expert. So I'll get that mechanical engineer and have them come down and help me redesign a part. I'll go get that electrical guy that can help redesign the electrical system so it runs smoother. I'll get that computer programmer who can change the process or how the machine is running and doing its thing and fix that automation so it's running smoother. So I'll pull in those subject matter experts who are experts in their area. And I know enough to communicate in, if you want to call it, their language. Because, everybody speaks their own language, especially when you're an expert in one specific area.
Yeah, I totally understand that. So at IDEX, I'm hopeful that most of the people who listen to this know what IDEX does. But if they don't, I was actually hoping you could give us a super quick overview. And then, this is the part that I find wildly fascinating because IDEX is essentially care for animals, the vast majority of its work. And you can explain it much better than I can. So having a process engineer is not intuitive. So your role there is a really great example of how organizations sound like that they're just doing one thing, but they need a whole bunch of people to get to that one thing.
Correct. So IDEX is a company that really, we have 3 major areas. We try to keep your pets healthy and safe. We're trying to keep livestock clean so that when it becomes food for us, that we're not going to get sick. And we also have a water division that is trying to keep people safe. So really, we're broken up into, we have a small animal diagnostics, which when you go to a veterinarian and you take your dog or your cat in, we make all those things at the veterinarian. We make the actual tests to see what could be going wrong, like Lyme disease or heartworm or things like that. We also make the instruments in the back room that run the hematology and the blood testing and the chemistry testing of the blood itself. We have a livestock, poultry, dairy business, which is monitoring the quality of milk that we drink and also herd and flock animals worldwide. So you're talking like cows and pigs and chickens and turkeys that we would eat. We have a water testing business that will ensure that drinking water is clean and safe for the world. And for that, we support about 2.5 billion people worldwide. Our equipment is everywhere throughout the world. We are a worldwide company. We have facilities on 6 of the 7 continents. So we don't have a penguin test, but I'm really rooting for that Antarctica to come in and make 7 out of 7 for us.
That would be so cool.
That would be awesome. But I think we're going to be doing that, but our water goes worldwide. So we do have a presence on Antarctica with some of the stuff that we sell down there. And I've heard that some of our water tests were actually up on the International Space Station. So we are truly a universal company.
So do you work across all three of those divisions, or do you have a particular area that you're working on? And this is where you get to dive into what it is you're doing right now.
So I'm going to answer that in two ways. 3 years ago, I used to work in one area. I was in the SNAP production area. And that's that tag or companion animal group is what we call it for your dogs and your cats. We make the diagnostic tests that would go to a veterinarian. And that's really where I focused my life at that point in time. About 3 years ago, I moved from being a process engineer to an engineering manager. And when I moved into this group, it was a brand new group that was created at the time that actually covers all the different lines of business. So I now deal with the chemistry side of things. I deal with the hematology side of things. I deal with our digital radiography group. We have digital x-rays. I still deal with the assays that we make for our dogs and our cats, also for the livestock, poultry, dairy business. I'm not really involved in the water area yet, but very well might be in the future to get something different moving forward. Yeah.
Yeah, hopefully people, after they listen to this, they're going to dive right into the 5-Minute Genius video that by the time this gets released will be out there, which I thought was a really cool synopsis of how you do what you do. So if you could pick a project, it doesn't have to be that one, and just kind of step us through what it looks like for you to do process engineering in any one of those areas.
So the example of my 5-Minute Genius, and this is a good one, is we changed the wrapper for one of our devices. So our device is wrapped in foil so it stays safe and stays protected and stays clean before it gets to the customer. We changed that foil from one type of foil to another. And as part of what I do now is I have to validate that change, make sure that what we did didn't affect the assay in any way, meaning it still works properly, and meaning that the user or the customer at the other end doesn't see anything really different. So because we're on a phone call and because, no one can see this on a podcast, think of a candy bar. And that candy bar is wrapped in a foil or a wrapper, and you're changing that wrapper. What I did was I stepped through the process with a team of people, going from the beginning to end to identify all the things that could possibly break in the system. Things like, does it still seal at the end? Does it allow air to transfer through and affect the taste of the candy bar? Does it still fit in the box? Is it thicker? Does it not fit in the box anymore? Those types of things that we look at. But it's a very structured process to get from point A to point B. Going through all that, I designed the testing. We got the right samples in. We ran it on our lines. We looked at the amount of pressure it took to open it up. We looked at the way it printed. We looked at everything about it. We looked at how it affected our assay. We tested assays to see if there was any leaching out of the foil or anything like that. We tested everything, and just to make sure that it was good. When we put it on the line at the end, to spoil the 5-Minute Genius, I actually missed something. But we did find it during our final bit of testing, so I was able to still make sure the customer didn't get it. But I did miss something, and that's why we try to do this focused procedure to identify all the things that could possibly break and challenge those things and make sure that our customer is always protected and they get something that they can use. And it turns out that you couldn't open the wrapper. It was very difficult to open it. That's kind of a problem when you want to get to the thing inside.
I'm curious, why did you decide to change what was working?
In what way? What I was doing?
No, I'm sorry. You changed the foil.
Yep.
Why change the packet?
One of it was cost. We could get it cheaper. And the other was they were changing the foil to reduce some of the waste at the supplier end. We buy the foil from another supplier. They make it for us. They proposed to us making a change to the way they manufacture it to make it easier for them to manage and to reduce some of the waste on their end. There was a chemical in there, some sort of solvent that they were using in the glue when they laminated it that they wanted to eliminate. And by removing that from the waste stream, one, it was less going to a landfill and less chemicals that had to be disposed of on their end. They proposed it to us, and we looked at their change, went through the whole change, tested it, made sure it worked, and then we implemented it.
So how often are the changes that you analyze implementing your processes? How often is it spurred by internal ideas or concerns? And how often is it because the suppliers that you work with are either need to change or want to change what they're doing?
I think it's probably 60-40 internal to us, just because we have a lot of manufacturing processes that we are changing. So it's probably even more 70-30 to our side, because not everything that we do is material related. Some of it is process related, how we assemble something. So if you're thinking of putting together like a toaster, you have to put the screws in here and you get the housing and then you lock that down. Well, if the screws have to be torqued down to a certain level, maybe we're changing the type of screw and it's a different torque value. So that's an internal process on our end where we have to change the torque value. And that would be something that we create on our own. A lot of our instruments have computer systems in them. And if we're changing the way that's running in the background, that's an internal change to us. It's just programming changes. But a lot of times we do get calls from a vendor saying, hey, we can't get this part anymore, but we can get this part that's virtually identical. So you're going to have to change that. Or they work with us to try to, like with the foil supplier, where they propose something to us and we accepted that proposal and actually went through the test.
Is there a difference in fun in either project? Like if you guys come up with one, is that more fun than the challenge of working with an outside supplier? Maybe fun's not the right word. It sounds like it's all fascinating, kind of gives you a chance to do this broad overview. It also seems like if you don't have total control over it, it forces you to rethink more things. So that to me seems like it might be more fun.
I wouldn't say it's more fun. Sometimes the most fun things are when something is actually going wrong on our end and we're looking to try to find what the problem is. Then we find the problem and have to implement a solution for it. So if we're getting calls from our customers that are saying something when they run a certain instrument is doing something weird, we look into it, find that solution, figure out what that root cause is, and then dive into a solution for it. Those are usually the most fun versus a change where either we promote it or our customer promotes it. So sometimes the challenge of figuring out why it broke and fixing the why it broke by implementing a solution is the most fun.
Do you ever feel like you and your team have totally fixed a process so that you can just ignore it from then on?
Never. You can always make something better. It's called continuous improvement. Our goal is to take the big things first and fix all the big problems that we have. But if you think about it in terms of a boat on water, your boat is your process. The water are all the problems that you have. Or the water is all those things in your process that are hiding the problems, which are the rocks on the bottom of the seafloor. As you try to get rid of some of those wastes, that water that's in there, the boat is riding lower and lower and lower. And as soon as you start exposing some other problems, those are the rocks. You see those rocks, you get rid of those rocks. Now you can lower the water even more to expose more rocks and more rocks and more rocks. So the goal here is to get rid of all that waste to expose your problems. See that it's all those Band-Aids that you put on to make something work. So if you're driving a car and your tail light is a little loose and you put a piece of tape on it, well, the tail light's there, it's still working, but is it fixed? No. If you remove the tape, you expose the problem, the tail light's falling off. You can go in and fix the tail light, get it where it's supposed to be, and then that is gone. But now that might expose the problem of some paint chips on the back fender because you remove that tape. And as you kind of fix one problem, it exposes another and exposes another and exposes another. So it's always something to work on.
I was pretty sure that was the answer, but I wanted to make sure I wasn't just assuming. So All right. Do you have a favorite project, and it doesn't have to be with your current job with IDEX? Do you have a favorite project that surprised you in either what you learned or what had to be done to fix it?
Yeah, when I was in the automotive phase of my life, we were installing a piece of automation that was making a tie rod end. So the tie rod end is in the steering and suspension components of your part. So that's what we were making. And we installed this machine, came in from Japan, and we put it onto the floor. And I was in charge of making sure it worked, making sure all the pieces worked. I realized that we missed kind of when they made the instructions, it wasn't in English. So I had to write up the instruction manual for our operators in English because obviously it came in Japanese. I didn't read Japanese. I didn't have anyone who could translate for me. So I had to go through that machine and learn every intricacy of it and write up this procedure for operators so that they could run it and they could fix it when things jammed, and a replacement manual for our technicians who had to do the repairs. So I got really, really in depth with this piece of equipment. And it was a blast. I had a great time because I would just go down there and watch the machine run and stare at this section of it for like a half hour to an hour and just watch it and write down little notes. And then I went back to my desk and wrote it down in that language that the operators could understand. I meant English to English because I use all kinds of vernacular that our operators might not understand. But that was so much fun because it was just me doing it. And it was important because if I didn't have it, we wouldn't be able to run later.
That's really cool. I wonder if you'd have a head start nowadays with the ease of at least getting the beginning parts of translation done online.
Yeah, I think it would have helped a lot. On the other hand, I put it into a format that's more familiar to our operators too. So every business has their paperwork in certain formats and people are used to looking at it that way. So I took a lot of that information and put it in a format that we understood. But absolutely, if I could have used something like Google Translate now, that would have been awesome.
Yeah, that will be an indicator right there to our listeners about how old you and I are. So, Dave, this has been really great. I so enjoy talking to you because you have such a passion for a part of engineering that I think most people don't realize is so important in manufacturing and other things. And you make it make sense in a way that is really easy to understand. So it's always been fun for me to talk with you.
Thank you very much. It is a passion to me, and I do enjoy what I'm doing. And as I said before, because I have to speak to different types of engineers and different managers and different operators, I've learned to speak and translate everything to my audience and understand who the audience is. And if they're very technical, I can go really technical. I can go deep. But if they're not as technical, I can stay more on the surface and explain it a little bit better.
Yeah, it's a really important skill, and you do it in a way that doesn't feel like pandering in any way. It feels like totally understands how I have to understand this. So I just wanted to let you know that I've always really enjoyed talking with you, but I've also enjoyed watching you communicate with other people.
Thank you.
So,
thank you.
You're welcome. I don't have anything else. This has been a great conversation. I feel like we have opened the window a little bit or opened the curtain to let people know what process engineering is, or manufacturing systems engineering, or in my world, industrial engineering. You can tell that no one can quite decide what to call it, but it's actually a really critical part of systems and how modern businesses work. So I really appreciate you providing some background and information about that. And more importantly, I appreciate the science that you're doing for Maine and the science communication. I think it's really important, and I'm grateful for it.
No, thank you very much for everything that you do. And I like to have the opportunity to let everybody know there are other types of engineers out there in the world. There are people like me, and what the types of things that IDEX can do for the community as well. And you can be any type of engineer you want to be, and you just find what interests you, what kind of passion it is for you, and you can find a place.
This was really great. I really appreciate it. Thanks, Dave.
Thank you very much.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. The Discover Maine theme was composed and performed by Nick Parker.